तुम्हारा सेकंड टर्म नहीं होता फिर?
सर इस बार इन्होंने थोड़ा चेंज कर दिया। इन्होंने हमारे दो 40-40 मार्क्स के ले लिए एंड सिलेबस खत्म करने के बाद अब अक्टूबर में सीधा प्री बोर्ड।
अच्छा अच्छा।
यस सर।
है ना? मैं देखा। हम्म। ये है ना? क्वेश्चन 11। क्वेश्चन 11 के पार्ट्स हैं वो हम कर रहे हैं। क्वेश्चन 1, 5, 7, 9, 10, 17, 19, 27, 35, 53। ये कर लो। All these questions are, question 11 is basically contains, सारे क्वेश्चन जो कि बाय पार्ट्स वाले हैं। कैमरा ऑन कर लो एवरीवन। क्या है फर्स्ट क्वेश्चन? ओके। ऑलवेज स्टार्ट बाय टेकिंग इट as I. You have algebraic function, you have a trigonometric function. So trigonometric function to be integrated and algebraic to be differentiated. कर लो। शनाया, जानवी, जैना करो। ऑन करो, कैमरा ऑन करो।
यस सर।
So that's the answer. We differentiate x, we integrate sine 3x. Algebraic and trigonometric, so you differentiate x square, integrate sine x. But you have to apply by parts two times. X square integration of sine x is minus cos x. I'm writing down directly now this time. Minus minus plus, 2 is out. Again, differentiate x, integrate cos. It's question 11, various parts from the assignment of integration. So when only one function is there, we can always take other function as 1. 1 log x. And in these kind of question, 1 would be always integrated. So integration of 1 would be x. Derivative of log x would be 1 by x. So remember that integration of log x is x log x minus 1, which you can also write as x log x to the base e minus log e to the base e, because log of any number to the same base is always 1. And you might find answer like this also. X log e x. Next question is 9. 9 is sine inverse. The sine inverse x you can integrate in two ways. Like you can take one as, one function. Or the second method is you can make substitution first. What is that substitution? Let sine inverse x be equal to t. That is, x is equal to sine t. Differentiate dx is equal to cos t dt. So the integration would be sine inverse x is t, dx is cos t dt. And then you can apply by parts. You can convert the function like this. Sine inverse x is equal to t. X is equal to sine t. Differentiate dx is equal to cos t dt. Then it's quite easy to integrate t cos t. T as u, cos t as v. So integration of cos would be sine. Derivative of t would be 1. And then integration of sine would be minus cos. And since sin x, sin t is x by 1, you can draw a triangle, right triangle. Sine of t is perpendicular by hypotenuse. The base would be 1 minus x square. So t is sine inverse x. Sin t is x. Cos t is under root 1 minus x square. The second method would be that you take u as sine inverse, v as 1. So sine inverse x as it is, integration of 1 would be x. Derivative of sine inverse x is 1 over under root this. Integration of 1 is this. And then you can use substitution. Or you can also apply the ready-made formula. For that, you have to make slight rearrangements. I've taken minus n inside. Next step, I multiply by 2, divide by 2. And then we use that formula. This is straight away under root 1 minus x square plus c. Over here, I've used this result. Integration f dash x by 2 root fx dx is always root fx. I've used over here. This is fx. Its derivative is minus 2x. This is 2 under root fx. So you can always use this result. Or else this is the best. Sine inverse x is equal to t, x equal to sine t, and then differentiate. डायरेक्टली कर सकते हो, हाँ ठीक है। ये इससे भी इजी हो जाता है कई बार ना, ऐसे भी कर सकते हो। tan इनवर्स एक्स को नहीं, tan इनवर्स में यू डोंट नीड टू सब्स्टिट्यूट t, बट sin इनवर्स एक्स होल स्क्वायर sin इनवर्स एक्स, दिस इज बेटर। In tan inverse x, you can take 1 and integrate. It'll be easy. Take v as 1. So integration of 1 is x, tan inverse x as it is. Derivative of tan inverse x is this. So now what you do, you multiply by 2, divide by 2, and you use a ready-made formula. Which ready-made formula? If you have f dash x over fx, its integration is always log of fx. If the derivative of denominator is present in the numerator, you can straight away write log of x. So integration of 1 plus x square is in the numerator. So 1 by 2 log of denominator. That's your answer. F dash x by fx is log of fx. Rin, which question you answering?
Third is 1.
Okay. Chirag, Anuj.
Sir, 17th.
Okay. What is 17th? Sine root x. If you want, you can make this substitution so that root goes away. then this will be 2t sine t. You know how to integrate this. If you make a substitution, x is equal to t square, it will be 2 into t sine t. Easy. क्या किया तुमने? ठीक है, इसको इंटीग्रेट कर तो बढ़ता जाएगा, वो उल्टा करना पड़ेगा तुम्हें, सब्स्टिट्यूशन करना ही पड़ेगा, इस एंड पे सब्स्टिट्यूशन कर लो। वैसे तो था यहीं पे, यू मेक ए सब्स्टिट्यूशन ओवर हियर ओनली, सो 2 is out, t you differentiate, sin t you integrate, integration of sin t is minus cos t, so minus t cos t, this would be derivative t is 1, this is minus cos t plus cos t, so integration is sin t. Now you make the substitution, t is root x, that's your answer. So it's easy when you take root x as t or x as t square and then differentiate. What is question 19? Right. For this question, the same method, sine inverse x is equal to t, but don't differentiate it. Get sine other side. X equal to sine t, so dx is cos t dt. So this would be t square cos t dt, which is quite easily integrable. Let sine inverse x is equal to t, so x is equal to sine t. I need to apply integration by part 2 times over here. टी स्क्वायर को डिफरेंशिएट, हाँ, अब इसको इधर लाओ पहले, फिर वो करना डिफरेंशिएट, नाउ डिफरेंशिएट. Then again you apply, take 2 common, apply by parts again. Then you replace sine t cos t. Can form triangle, right triangle. Sine t is x by 1. T square. T is sine inverse x. Sine t is x. Minus t cos t. T is sine inverse x. Cos t is under root 1 minus x square. Sin t is x. So this is the answer. X sin inverse x whole square minus 2 minus under root 1 minus x square sin inverse x plus x. $27 is important question. No. Sin inverse x plus cos inverse x is pi by 2. You have to use this. Sin inverse x plus cos inverse x is equal to pi by 2. हाँ, it will hold true. Yes, yes. X से कुछ भी होगा, it will work. Sin inverse root x plus cos inverse root x is pi by 2 in the denominator. In the numerator, replace cos inverse root x by pi by 2 minus sin inverse root x. Do it yourself. Sin inverse x plus cos inverse x is pi by 2. Therefore, sin inverse root x plus cos inverse root x will be also pi by 2. And cos inverse root x you can replace as pi by 2 minus sin inverse root x. So this question now reduces to sin inverse root x minus cos inverse root x, which is pi by 2 minus sin inverse root x divided by pi by 2 dx. This is 2 by pi 2 sin inverse root x minus pi by 2. So this is 4 by pi sin inverse root x dx minus 1 dx. So this I take as pi I1, integration of 1 is x. And we can integrate this I1 individually, separately. Now integrate I1, which is sin inverse root x dx. Again, the substitution, sin inverse root x is equal to t. So root x is equal to sin t, or x is equal to sin square t. Now differentiate and solve. So dx is sin 2t dt. So the integral now is sin inverse root x is t. T sin 2t dt. T as u, sin 2t as v. Integrate it. Integration of sin 2t is minus cos 2t by 2. Integration of cos 2t is sin 2t by 2. But the problem is that we don't have, we have sin t की value. Sin t is root x by 1. So the hypotenuse would be sin t is root x. Hypotenuse will be 1. So the base would be 1 minus x. So we have sin t, we have cos t, but problem is we have answer in terms of sin t cos t. So let's convert cos t in terms of sin t. Cos 2t is 1 minus 2 sine square t. And sin 2t is 2 sin t cos t. 2 cancels out. Sin t cos t by 2 plus c. Now you make substitution. T is sin inverse root x. Sin t is sin square t is x. So 1 minus 2x by 2. Sin t is root x. Cos t is under root 1 minus x. That's your answer. Question 35.
Excuse me, sir.
Yes,
Sir, we haven't done inverse trig yet, no?
I did formula of inverse trigo in set relation function.
Okay, sir.
I did derive the identities of inverse. Yeah, question. So you make some substitution so that the under root goes away. Some kind of substitution so that under root is not is removed. So this I1 will substitute over there. Okay, then that you'll get the final answer. This is only I1 which has to be substituted in this. Because the question was I is equal to 4 by pi I1 minus x plus c. So this I1 will be substituted over here. Question 35. क्या था question? I is so first we need to get rid of under root. So what kind of substitution? Let's take x is equal to a tan square theta. So using this substitution, under root will go away, and dx would be a 2 tan theta. Derivative of tan theta is sec square theta d theta. Now integrate it. After the substitution, simplify and then apply by parts. One plus tan square theta is sec square theta. If you want, you can convert everything to sin and cos in the end. If in place of a plus x, it was a minus x, then we'll substitute x equal to a sin theta, a sin square theta. So 1 minus sin square would be cos square. But since we had a plus x, we substituted a tan square theta. So 1 plus tan square is x square theta. A will cancel. One plus tan square theta is x square theta. Can take 2a out. Tan square theta by sec square theta is sin square theta. Sin inverse of sin theta. Sin inverse of sin theta would be theta. And this tan theta into sec square theta is integrable. This you differentiate, this you integrate.
Excuse me, sir.
Yes.
Sir, इसमें can't we keep the d theta stuff like dx only and theta को हम वापस in terms of x डाल दे?
That way also you can answer it.
Okay.
So in that case, your theta would be, this integral would be tan inverse root x by a, right? So integration of this you have to integrate it individually, you can integrate separately also by substitution. Derivative of tan theta is sec square theta. So if you take tan theta as t, its derivative is already there. So it will be t dt. So it will be t square by 2. That will be tan square theta by 2. So theta as it is, integration would be tan square theta by 2. Derivative of theta is 1. Integration is tan square theta by 2. Then you know how to integrate tan square theta. And multiply 2 inside. So how would you integrate tan square theta? Sec square theta minus 1. Integration of sec square theta would be tan theta and 1 would be theta. And then you can replace. Theta is tan inverse root x by a. Tan square theta is x by a. So now tan square theta is x by a. Tan theta is root x by a. And theta is tan inverse root x by a. So this is a into theta. Tan square theta is x by a. Minus tan theta is root x by a. Plus theta is this is root x by a, no? No, it was this only. Theta, tan square theta was x by a, okay? So your answer would be x tan inverse root x by a minus root ax plus a tan inverse root x by a. नेक्स्ट कौन सा है 57 है ना नेक्स्ट 53 ओके क्वेश्चन 53 देखो इसका डेरिवेटिव ये है और इसका डेरिवेटिव ये है, तो इस पूरे को टी डालो। नहीं, साइन इनवर्स का तो ये हो गया है ना, और एक्स स्क्वायर का एक्स आएगा, एक्स स्क्वायर अलग कर लेंगे हम। Here, if you notice, derivative of x sine inverse x square is already there. X cube you can write as x square into x. First, you have to make substitution. Let sine inverse x square is equal to be t. So when you differentiate this, it will be 1 over 1 minus x4. Hmm? Hmm. So x dx divided by 1 minus x to the power 4 would be dt by 2. So this term is now dt by 2. And x square is sine t. Sine t, t and dt by 2. So after this, you can apply by parts easily. Integrate sine t, differentiate t. Sine t is x square by 1. Sine t is x square by 1. So base would be 1 minus x4. So now you can replace t cos t. What is t? T is sine inverse x square. Cos t would be base by hypotenuse. And sine t is x square. ठीक है. How would you integrate under root of a square minus x square dx? Using by parts. So you can integrate it by taking 1 as another function which is to be integrated. Do it. Integrate 1, differentiate this and get the result. Differentiate this. Integration of 1. Take 2 out. Will be minus x squared by under root of a square minus x square. After this, what do you do? You add a square and you subtract a square. 1 minute. There will be 2 also here. This 2 and this cancels out. Adding a squared. Now we divide individually. This by this by this. So this would be under root of a square minus x square dx. And this would be minus minus plus a square out dx divided by root of a square minus x square. And now notice one thing, that this is nothing but I. This is the integration I only. This I get on the left side becomes 2i. Integration of that is sine inverse x by a. So this is the result which you have to now remember. I derived it so that in case you forget it, you can derive. Now I'll tell you a simple way to remember this result. There are 3 such results. Simple way to remember these results is this. Suppose you want to remember the result of root of a square minus x square. So what you do is you write x by 2 here, and then you write a square by 2. This sign would be plus if a square is plus. This sign would be negative if the a square is negative. So whatever sign of a square is, you write there. So you write x by 2, you write a square by 2. The next is x square minus a square. So you write x by 2 here, you write minus a square by 2 because a square is negative. Third result is write x by 2 here, a square by 2 there. So sine of a square by 2 would be the same as that of the sine of a square in the question. Now, this term you have to write as it is over here. This term you have to write as it is over here. And for the next term, if imagine this is in the denominator, 1 over under root a square minus x square, integration of that, it would be sine inverse x by a. If this was 1 over x square minus a square, it will be log x plus under root x square minus a square. If this was in the denominator, it will be log x plus under root a square plus x square. So this is the way you remember this. Oh, assignment. So these 3 formula you have to remember. Question 14. You answer question 3 and question 16. Convert into perfect square, then decide which formula to be applied. Seven x minus 10 minus x square. Take minus sign common. 7/2. You add the square, you subtract the square. Nine by 4. So this is, take the minus sign inside. So this question is basically of this kind. A square minus x square. It is a square minus x square. So how to integrate x by 2 over here? In place of x, I have x minus 7/2. this as it is. Then a square by 2 with sign of a. A square is positive, so a square by 2. And then if it is in denominator, it would be sine inverse x by a. So this is the answer. Sixteenth question. In the 16th question is basically this type. When you have a linear term with under root of px square plus qx plus r. How to answer these kind of questions? So this linear term you write as a into differential of quadratic plus b. And then find a and b. Find capital A and capital B. What is the question? It's 3. So according to this, 2x plus 3 is the linear, equal to a into differential of that, which is 2x minus 4 plus b. Compare, find a and b. Okay. So 2x plus 3 is equal to 2ax minus 4a plus b. So 2a is equal to 2. So a is 1. And the constant term is 3 on the left side. Right side is minus 4a plus b. So b is 7. That means this linear factor can be replaced by this term. That is, this integral now will be 2x minus 4 plus 7. Don't open it. Under root x square minus 4x plus 3. Now divide into two parts. This into that. One integral is this. And the second integral is 7 into this. So we have divided integral into two parts. In the first part, derivative of this is present in over here. So let this is equal to t square. So 2x minus 4 dx is equal to 2t dt. So the first part you answer using this substitution. Second part, perfect square. So the first part will be, this is dt, yes. Under root of t square, 2t dt. Second part, convert to perfect square. X minus 2 whole square minus 1 dx. So this is 2t square, which is t cube by 3. And here you can apply the formula again. It is x square minus a square. So there will be negative sign. Write x by 2 over here. This term as it is. Here you write a square, which is 1 with negative sign by 2. And if it were in the denominator, it will be log. So whenever you come across linear into this, apply this. Linear is equal to a into derivative quadratic plus b. Then you come across those questions where you have e to the power x fx plus f dash x. E to the power x into fx plus f dash x. Derivative of fx is present in the... So answer for these questions is always e to the power fx. This is a result which you can remember. For example, if you have e to the power x into log x plus 1 by x. So we know that derivative of log x is 1 by x. So this is fx and this is f dash x. So answer would be e to the power x log x plus c. Question 12, part 7, you can answer. It is e to the power x square plus 1 over x plus 1 whole square. So you convert this integral into two parts. So that one part is derivative of the second part. Sometimes the question is not direct. You have to convert to that form. So Mira, what to do?
Sir, so first in the numerator we'll add 2x and subtract 2x, फिर वो
Yes.
whole square बन जाता है, फिर split कर दो, and then एक का कट के 1 हो गया, then the other part उसमें +1 -1 डाल दो.
Perfect. So adding 2x and subtracting 2x. This is x plus 1 whole square minus 2x divided by, divide individually, still it is not in that form. So what we do? Open the bracket, integration ex dx. Integration of ex would be ex only. This part you again rearrange. Now you notice one thing, that its derivative is x. So derivative of this is this. So the answer would be ex into fx. Question 8. So in the question 8, you don't have any e to the power x or something. So what do? You take log x to the base e is equal to t, convert this into exponential form. This base comes over there, and you replace dx by e to the power t dt. So this is the substitution. After the substitution, it is t divided by 1 plus t whole square e to the power t dt. which is basically the same question, the previous one. Add 1, subtract 1, and divide individually. So the answer would be e to the power t into 1 over 1 plus t. Then you substitute it back. E to the power t is x over 1 plus log x. The final answer is x over 1 plus log x. So now you practice more questions. Next class, that is Saturday, I'll be doing MCQs of entrance level. Meanwhile, you practice all these questions, finish them off, and then this mixed questions also, no? Some important questions. Also do them. So Saturday, I'll be doing, MCQ entrance level questions. Ending the class.
Thank you, sir.
Thank you so much.
Thank you, sir.